Hi, I'm Sergio, and this is my chemistry and my life project on ocean acidification. From 1751 to the 1900s, there was an increase of 30% of acidity levels globally. The ocean absorbs about one-third of CO2 emissions. These CO2 emissions come from a byproduct of fossil fuels. Acidity in the ocean has a harmful effect to marine and coral life. It reduces the amount of chemicals the marine life uses, which decreases their metabolical process and can harm their skeletal system. This can affect our life as the marine life food chain becomes more vulnerable, which will hurt commercial fishing. In this graph of historical projected pH and dissolved CO2, we see the level of CO2 increase as the level of pH decrease. Okay, so what I'm going to do now is I'm going to simulate CO2 being emitted to the ocean by pumping this bike pump with CO2 into this glass of water, and then after I'm going to test the pH levels of this glass of water and compare it to this glass of water. Okay, as you can see, this pH test strip is darker, which means it has a higher pH level than the one with CO2 emitted into it, which makes it more acidic. So, the chemistry behind acidification is water chemically reacts with CO2 to create carbonic acid. Then the carbonic acid dissociates in an equilibrium reaction to create carbonate and hydrogen ion. There's another reaction which carbonic acid dissociates to bicarbonate and hydrogen ion. So the problem with the ocean being more acidic is that the hydrogen ions chemically react with carbonate to create carbonic acid, and this leads to a decrease in carbonic acid in the reaction with calcium and carbonate, which creates calcium carbonate, which is an essential chemical in scalefish skeleton. And one of these are coccolithores, which we are seeing a decrease in the size of their shells, and this is bad for the environment because they help form clouds.